Hello everyone, welcome to Gate Academy. In this session, we will discuss how negative numbers are stored in computer. First of all, sir, what computer understand? 1, 2, 3, 4 or 0 and 1? Sir, computer only understand binary. We have already discussed binary number system, decimal number system, octal number system and hexadecimal number system. That means computer only understands 0 and 1. Sir. For a human being, that means persons like us, sir, how we get to know that it is a negative number? Because we have something called as sign. But this is a symbol in human language. This is a symbol in human language. But sir, but computer only understands 0 or 1. That means if we need to specify negative or positive, that is sign, sir, we must do this only by these symbols. So let me start, sir. First method, there is first method called as signed magnitude. Signed magnitude. Don't worry about this name. It may be there that some book will refer it to some other method, but focus on method. Sir, what does signed magnitude say? Sir, signed magnitude says that let me assume that integer is of 1 byte or 8 bit. You can also assume 2 byte. The story will be same. Sir, let us assume that the integer is of 1 byte, basically 8 bits. 1, 2, 3, 4, 5, 6, 7 and 8. Sir, so what does signed magnitude method says? That 1 bit is reserved for sign. That means, sir, the most significant bit represent the sign of a number. And how you can represent sign? Sir, there are two signs. Either a number could be positive or a number could be negative. And in binary number system, we have two symbols, 0 or 1. That means, sir, what is the assumption? That if it is 0, that means it is a positive number. And if the sign bit is 1, that means it is a negative number. That means 1 bit is reserved for sign bit and remaining bits represent the magnitude. Remaining bits represent the magnitude of the number. For example, let me represent plus 4 in such a system. So sir, for 4, what is the binary of 4? Let me calculate. Sir, the binary of 4 can be calculated by successive division by 2. So when 4 is divided by 2, quotient is 2 and the remainder is 0. When this 2 is again divided by 2, the quotient is 1 and the remainder is 0. When this 1 is divided by 2, sir, the quotient is 0 and the remainder is 1, and we need to stop because the quotient becomes 0. So what is the binary of 4? Sir, the binary of 4 is 1, 0, 0. Okay, let me write. Sir, if we have 8-bit integer, I'm just assuming, don't think much. Just understand the concept first. Sir, this bit is reserved for sign and these 7 bits are reserved for magnitude. Sir, plus 4, the binary of plus 4 is 1, 0, 0. Let me store 1, 0, 0. Here we have 7 bits, sir, fill zeros. So what is the number? Sir, 0, 0, 0, 0, 1, 0, 0. But because it is a positive number, what should be the sign bit? Sir, the sign bit must be 0. 0 means positive. As simple as that. Okay, sir. What if I want to store minus 4? Sir, the binary for 4 is still 1, 0, 0. The binary equivalent of 4 is 1, 0, 0. Okay, sir. That means for negative number, what we are doing? Nothing. Magnitude. Talking about magnitude, the story is same. That means, sir, This bit is for sign bit, but what about the magnitude? See, the magnitude is same in both the cases. If I talk about 7 bit, last 7 bit, sir, same. But, sir, this MSB is reserved for sign. And just because it is a negative number, what should be the sign bit? Sir, the sign bit must be 1. So that's how we can store positive as well as negative number in computer using signed magnitude representation. Signed magnitude representation. The story is very simple. The story is very simple. Don't focus on positive or negative. Find the binary equivalent. And if the number is positive, put the MSB as 0. If the number is negative, put the MSB as 1. Done. That means, sir, if I talk about something like let us suppose this is the number. This is the number. If I show this number to a computer or if this number is stored in computer, sir, what is the value of this number? What is this number? See, firstly, sir, this is the sign bit. This is the sign bit. And because it is 1, sir, that means it is negative. Now, sir, coming to these bits, sir, what is the magnitude? What is the magnitude, sir? We will find the decimal equivalent of them and put it here. So let me find 0, 0, 0, 1, 0, 1, 0. Sir, while calculating the magnitude, sir, do we need them? No, but still, if you are interested, 2 to the power 0, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. Although we don't need them, for sure, you know everything. Sir, what is the magnitude? Sir, 0 into something, 0 into something, 0 into something is 0. So, 1 into 2 to the power 3 plus 0 into something is 0 plus 1 into 2 to the power 1 plus 0 into something is 0. That means what is the magnitude? 8 plus 2, 10. So, what is the number? The number is actually minus 10. The number is actually minus of 10. That's how computer can calculate. Okay, sir, done. Sir, what is the problem with this numbers? What is the problem with this number representation? See, if I ask you that, let us assume we have 8-bit number. What is this number? Sir. Because of this 0, I get to know plus, and because of all of them as 0, what is the magnitude? 0. Sir, because of this 1, I get to know the number is negative, and because of magnitude contain all 0, that means 0. Sir, this number representation will have 2 types of 0, plus 0 and minus 0. Is it so in mathematics? Sir, in mathematics, 0 is 0. 0 is 0. That means, sir, okay, you can say, sir, it falls in positive category, but still plus 0 and minus 0. Sir, why 0 have 2 representation? This is wrong. Try to understand. So, sir, this number representation contain 2 representation for 0. And basically, try to understand. Sir, second point. Sir, because this number representation or represent minus 0. Do we need minus 0 in any number system? No, sir. That means we are wasting one such combination. We are wasting one such combination of possible values that can be generated with 8 bits. Try to understand. Okay, sir. Then that is why the second number system came. Not number system, representation. Sir, we have ones complement system. I'm not going to cover ones complement because it's not within the scope. Then the third number system is 2's complement method. Let's try to understand what does 2's complement method says. That's how computer nowadays are working, using 2's complement method. So sir, what does it say? It says that for positive numbers are represented as it is. Are represented as it is. As it is, what does that mean? As it is, that means just find the binary of them, the work is done. That means just find the binary equivalent. That means if I say in this number system how to represent plus 11 if integer is of 8 bit. Try to understand. Sir, so for plus 11, let me find the binary equivalent of 11. Sir, 2 into 5 is 10. So basically it leaves a remainder 1. When 5 is divided by 2, leaves a remainder 1 and the quotient is 2. When 2 is divided by 2, the quotient is 1 and the remainder is 0. When 1 is divided by 2, quotient is 0 and the remainder will be 1. That means the binary equivalent for 11 is 1011. 1011. Sir, what are the values here? So, how plus 11 is represented like this? Sir, that means the sign bit is still same. Yes. Because for positive number, we are not doing anything. For positive number, we are not doing anything. We are just storing them as it is. Okay, that means, sir, try to understand. Sir, still the MSB is 0 for positive numbers. Try to understand. Sir, what about negative numbers? The negative numbers are stored in 2's complementation form. In 2's complementation. What does that mean? Sir, plus 11 we know. That means if someone says how minus 11 will be stored, then what is the procedure? Sir, firstly we will find the binary equivalent for plus 11. Firstly, we will find the binary equivalent of plus 11. Do we know it? Yes, sir, we know it. In 8 bits, we have 0, 0, 0, 0, 1, 0, 1, 1. Okay, sir. Then we calculate the 2's complement of plus 11. Sir, now we have two methods for calculating 2's complement of a number. Sir, what are those methods? The very first method is find the ones complement of the number. So how we can find ones complement? Sir, just flip all the bits. If it is a 0, make it 1. If it is a 1, make it 0. That means, sir, the ones complement of this number is 1, 1, 1, 1, 0, 1, 0 and a 0. So this is ones complement. Sir, now how could we find 2's complement? 2's complement is nothing but add a 1 in ones complement. That means whatever ones complement you have calculated, just add a 1. Ones complement plus 1. But always remember, this addition is performed in binary. That means if I try to add 1 to this number, what will happen? Sir, 0 plus 1 is 1. Then everything is same. That means 0, 1, 1, 1, 1. So this is the 2's complement for 11. That means how minus 11 is stored in computer? Sir, minus 11 is stored like this. Okay, sir. Try to understand. Sir, now let me reverse all the concept. Let us suppose I am saying this this number is stored in computer memory. How computer evaluate it? How computer recognize that this is a negative number? Try to understand. Try to understand. Why we have a 1 here? Why we have a 1 here? Because while calculating one's complement, it becomes 1 from 0. That means, sir, if I give this number to any computer, 1, 1, 1, 1, 0, 1, 0, 1, and ask what is the value of this number, computer will first look at this. Computer get to know because of this 1, that means this number is negative. This number is negative. Okay, so we got the sign. Now computer will think, okay, if this number is negative, that means it is already stored in 2's complementation form, because negative numbers are stored in 2's complement form. That means this number is in 2's complement form. To find out the answer, or to find out the value, sir, computer will do, what computer will do? Find the 2's complement of this number. Find the 2's complement of this number. Let me try to find out. Sir, how we can find the 2's complement? First, let me find the 1's complement. So, if it is a 1, make it 0. If it is a 0, make it 1. 1, 0, 0, 1, 0, 0, 0, 0. Okay, sir. Done. This is the 1's complement. See, we are again finding. Okay. And how to find 2's complement? Sir, just add a 1. Just add a 1. So, if I add a 1, sir, it becomes 1, 1, 0, 1, 0, 0, 0, 0. Sir, what is this? What is this? Sir, this is the binary for 11. That means now computer knows what is the magnitude 11. So that's how negative numbers are stored and negative numbers are interpreted by machine. Let me again tell you something. Sir, how this addition is going on? How this addition is going on? Sir, 0 plus 1. Everyone knows 0 plus 1 is 1. 1 plus 0 is also 1. 1 plus 1 is 2. But in binary, can we write 2? No, sir. That means, sir, what is, sir, 1, 0. That means whenever you add 1 and a 1, basically you are saying 1, 0. But we have to put only single digit. That means 0, and this 1 becomes the carry. This 1 becomes the carry, and this is the result. If you don't know it. So let me add something for you. Sir, if I say 0, 1, 0 and 0, 0, 1, 1. Sir, how this addition will be performed? Sir, 1 plus 1 is 2. But can we write 2? No, sir, we have to write 1, 0. That means 1 plus 1 is nothing but 0 and 1 is the carry. Sir, 1 plus 0 is 1 and 1 plus 1 is 2. Again for 2, we can write 1, 0. That means 0 and 1. Sir, 1 plus 1 is 2. 2 plus 0 is 2. 2 means 0 and 1 carry. 1 plus 0 is 1 and 1 plus 0 is 1. That means what is the result? Sir, this is the result of adding these two numbers. Sir, somehow it is becoming difficult because we are not good with the addition of binary numbers. Sir, is there any other way to find 2's complement of a number directly? Yes, there is another way. Try to understand. Finding 2's complement of a number. Finding 2's complement of a number. Sir, let us try to find the 2's complement of this number. Sir, initially let us try to find this. Sir, how to find 2's complement directly? See, from LSB, that is from right hand side, move and just copy all the bits. That means if it is a 0, make it 0. If it is a 0, make it 0. If it is a 1, 1. Sir, move from right hand side or LSB to MSB. Sir, just copy the bits until you get the 1, until you get the first one. That means, sir, I will stop copy the bits when I encountered a 1. Sir, 0, 0, 1. Okay, we encountered a 1. We encountered a 1. We encountered a 1. First one. Okay, then what to do? Then, okay, still move like this, but just flip the bits. If it is a 0, make it 1. If it is a 1, make it 0. If it is a 0, make it 1. If it is a 1, make it 0. If it is a 0, make it 1. That's how you can easily find 2's complement. Again, let me again tell you something. Sir. 0, 0, 0, 0, 1, 0, 1, 1. Sir. Okay, let's try to find the 2's complement of this. Sir, we will move from here and try to copy every bit. That means if it is a 0, make it 0. If it is a 1, 1. But when to stop this process? Sir, once we encountered first one, stop. Stop copying the bits. Okay, that means after this, whenever you get a bit, just flip it. That means if it is a 0, make it 1. If it is a 1, make it 0. If it is a 0, make it 1. 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 Done, sir. Done. So, this is the 2's complement of this number. Sir, let's try to find out 2's complement of plus 11. Sir, 0, 0, 0, 0, 1, 0, 1, 1. Sir, what is the process? Sir, just move from here until you get first one. But the problem here is, the first bit is itself is 1. Sir, okay, just copy it. But after this, just flip all the bits. That means if it is a 1, make it 0. If it is a 0, make it 1. If it is 1, make it 0. All zeros, make all of them as 1. That means what is the 1's complement? 1, 1, 1, 1, 0, 1, 0, 1. So that's how you can easily find out the 2's complement of a number. The 2's complement of a number. Sir, this is 2's complement of plus 11. That means, sir. Now, try to understand what we know. Sir. Positive numbers are stored as it is. For negative numbers are stored in 2's complementation form. Okay, let me again do something, sir. How minus 27 will be stored? Sir, because it is a negative number, it will be stored in 2's complementation form. But before anything, we need to find the binary equivalent for 27. So, let me divide. Sir, 13 times is 26 and 1 is the remainder. When I divide this 13 by 2, 6 times is 12 and the remainder is 1. When I divide this 6 by 2, quotient is 3 and the remainder is 0. When I divide this 3 by 2, the quotient is 1 and the remainder is 1. When I divide 1 by 2, the quotient becomes 0 and the remainder is 0. We need to stop because the quotient becomes 0. So this is the binary equivalent for 27. Okay, sir. Sir, what is the process? First we find the binary equivalent for plus 27. Okay, that means if 1, 2, 3, 4, 5, 6, 7. Sir, 1, 1, 0, 1, 1, 0, 1, 1, 0, 0, 0. Okay, sir. This is binary equivalent for plus 27. Positive numbers are stored as it is. So if you ask me plus 27, this is plus 27. Now, sir, we will find the 2's complement. Why? Sir, negative numbers are stored in 2's complementation form. Now, sir, how to find 2's complement? We know it. Do we know? Yes, sir. Sir, start copying the bit. until we get first one. See, sir, the first bit from right hand side is 1. That means now stop the process. Now what to do? Now for remaining bits, flip them. That means if it is a 1, make it 0. If it is a 0, make it 1. If it is 1, make it 0. If it is 1, make it 0. If it is 0, make it 1. If it is 0, make it 1. If it is 0, make it 1. So I am saying this is the 2's complement of plus 27. So can I say this number represent minus of 27? Yes, of course. Let me verify. Sir, verification is must. Sir, if I show this number to a computer, if I show this number, that is 111-00101. If I show this number to a computer, how computer will evaluate? Sir, firstly, computer will check the MSB. By this, computer get to know that the sign is negative. Okay. And computer get to know that this is a negative number. That means this representation is in 2's complementation form. So how to find the actual number? How to find the magnitude? Sign. We get the sign already. How to find the magnitude? Find the 2's complement of this number again. Sir, how to find the 2's complement of this number? 111-00101. Sir, start copying the bits from right hand side until you get the first one. Sir, we get the first one. Now flip all the bits. That means if it is a 1, make 0, make it 1, 1, 0. That means this is my number. Okay, that means 0, 0, 0, 1, 1, 0, 1, 1. Sir, what is this number in decimal? Let me check. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. We don't need them. So what is the number? 1 into 2 to the power 4, 1 into 2 to the power 3, 0 into 2 to the power 2, 1 into 2 to the power 1, 1 into 2 to the power 0. That means this is 16 plus 8 plus 0 plus 2 plus 1. That means 24 plus 3, 27. That means this number is minus of 27. So we get to know how computer will store and how computer will fetch. Both the terms are okay. Both the process are okay. How computer will store and how computer will fetch. Because for every number there is a sequence of 0 and 1. So how computer get to know which number is positive, which number is negative, how it gets to know which number is which. So this is the overall procedure, that is 2's complementation form. Before I move ahead further, let us try to understand, or let us try to find the value of a number in 2's complementation form. Sir, let us suppose I am saying, let's try to find out the value of this number directly. 0, 0, 0. Oh, not this. This one. 1, 1, 1, 0, 0, 1, 0, 1. Sir, let's try to find. Sir, this number is written in 2's complementation form. Okay. Sir, can we find the value directly? Yes, of course. Just focus on zeros. Focus on zeros. Sir. This is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. Focus on 0. 0, 0, 0. Sir. This is in 2's complementation form. That means negative numbers. Okay. Sir, how could we find the value? See, what is this? What is the place value for this 0? 2 to the power 4. Minus 2 to the power 4. Minus 2 to the power 3. Minus 2 to the power 1. And put a extra minus 1. Let me calculate. Sir, minus 16, minus 8, minus 2, minus 1. Minus of 16 plus 8 plus 2 plus 1. That means it is nothing but minus 27. Is it so? Yes, sir. Yes, sir. Sir, 1 extra minus 1 and for all the place values of 0 along with negative sign, just sum them up. You get the answer. Let me take another example. Sir, 1 0 1 0 1 1 1 0. Sir, is this written in 2's complementation? Yes, sir. By looking at this, we get to know that this number is negative. I am asking find the value of this number. Don't go for 2's complementation and all that. Sir, what is the place value? 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. Because I need to focus only on zeros. That's it. Sir, how to find the value? Minus of 2 to the power 6, minus of 2 to the power 4, minus of 2 to the power 0 and put a extra minus 1. So what is the value? Minus 64 plus 16 plus 1 plus 1. That means this number is minus 82. Great, sir. This is a great method. You can directly find the value of a negative number. We are working upon 2's complementation form. Let me cover the last question so that again clarity of thought will be there. Sir, how to store minus 43 and plus 43? See, for 43, we need to first find the binary equivalent. Sir, how to find? Let me divide 21 times and the remainder will be 1. When 21 is divided by 2, 10 and the remainder will be 1. When 10 is divided 5 times, remainder will be 0. When 5 is divided by 2, it goes 2 times and the remainder will be 1. When 2 is divided by 1 time and remainder will be 0. When 1 is divided by 2, sir, 0 times and the remainder will be 1. So this is the binary equivalent for 43. So plus 43, for plus 43, what is the representation? Sir, as it is, just write the binary equivalent. So try to find out. 1, 2, then 1, 0, 1, 1, 0, 1 and 0, 1, 1, 0, 1, 1, 0 and 0. So the binary representation for 43 plus 43 or 43 is this. But sir, for negative number, they must be stored in 2's complementation. So how to store minus 43? Sir, this is plus 43. Just find the 2's complement of this. Sir, from right hand side, just copy the bits until you get first one. Did we get first one? Yes, sir. Now flip all the bits. That means if it is a 1, make it 0. If it is a 0, make it 1. If it is 1, make it 0. If it is a 0, make it 1. If it is a 1, make it 0. If it is a 0, make it 1. If it is a 0, make it 1. That means this is the 2's complement of plus 43. So can I say minus 43 is stored in computer memory like this? Yes, sir. We get to know how to store, but how computer will read them? How computer will recognize them, whether they are positive or negative? Sir. If this is shown to a computer, if this is stored somewhere, how computer get to know? Sir, it will check the MSB. If it is 0, just find the decimal equivalent, you got the answer. If it is a 0, that means it is a positive number. So computer get to know plus. And what is the magnitude? Just find the decimal equivalent, 43. But if this is stored in memory, how computer will understand that it is negative number and how to calculate the value? Sir, if I show this number to a computer, computers understand. Please look here. Sir, by this one, computer get to know that the number is negative. What is the value? You have two methods. Sir, find the 2's complement of this and get the value. Find the 2's complement, you get a binary number, then convert that into a decimal number and find the value. And the second quick method is, sir, focus on zeros. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 7. Sir, what we are saying, focus on zeros. That means this, this and this. Sir, how we get the value? How we get the value? Try to understand. Try to understand. How we get the value? Sir, if we are trying to find the value directly, do we need sign? No, sir. Sir, that means, sir, how we get the value? Minus of 2 to the power 5, minus of 2 to the power 3, minus of 2 to the power 1 and put a extra minus 1. Sir, what is the value? Minus 32, minus 8, minus 2, minus 1. Take negative sign as common. 32 plus 8 plus 2 plus 1, that makes it minus 43. So that's how computer can evaluate it also. Done. I hope things must be clear to each and everyone who is watching this video. How negative numbers are stored and how negative numbers are fetched from computer memory. So that's all for this session. Bye-bye. Take care.